Hey everyone, I'm in a woodworking shop here and today's math is about making finger joint corners. This one is made especially bad. I try to make almost all possible mistakes that can be done on this. Most importantly, an additional mistake. That's a mistake in addition. Or because it's repeated addition, you can look at it as a multiplication issue where issues add up at each finger joint. So let's take a look at this one. What's wrong with this piece of board that used to be one continuous length? I just cut it in half and I joined it together like this. It looks like, hey, it's together and it's holding with some friction. It's not too gappy. Well, it's horrendous. Have a look at the gaps. This would need serious amount of filling and then sanding. So never mind the gaps opening up this way because it's not glued together, but look at the gaps, the horizontal gaps there, that one there is okay, that one is very gappy, that was even gappier, and that one is animals can walk through there, so wide. So besides that, of course, on this side I have fiber tear out everywhere and matching also on this side. So what happened here and what's wrong with the math and with the addition? Let me explain it. This piece of fence was used for producing these cuts on a table saw, not with this blade that I have on it, with a dado blade. I just changed it, but I have a story to tell you. So you're making a series of cuts this way and then move it over this way, move it over, move it over. This moving over is done with a bunch of spacer blocks. So you start here and then you remove two spacers. You have something clamped here as well, and then you remove two spacers, move the board over, remove two of these spacers, move the board over. You get the idea. So where is the problem of addition? Coming like that. I want to show you this. Of course, the dado set, it's a saw set, that comes like this. Out of these, dado, there we have it. Out of these blades you need an outside blade and another outside blade, and different thicknesses of these blades can be combined together with different shims that the manufacturer makes to produce a finished set of some dado blade setup. The thickness of this measured especially at the teeth, from outside teeth to outside teeth, and I don't know if the blades are yeah, no, it's wrong. So outside to outside there. So from outside corner to outside corner, this measurement here is critical. I'll show you the math now. So my dado set thickness was 12.35 millimeters. For the spacers, I just used 1/2 inch plywood, just anything out of the garbage can. How I measured the thickness, both the thickness of the dado set is of course with digital calipers that has 2 decimal places. That's important. So that's how I got 2 decimal places out of this. 12.35 was measured like so. The thickness of the plywood, the thickness of the spacers is not 12.35. This one is 12.67 at this end here, but this end is 12.8. It's very fine if it's a plywood, but it's not fine for fine woodworking. So 12.60 something at this end, and very definitely 12.8ish at this end. So the wood veneer, of course, it's coarse and rough, and that's what happens. This is 12.6 and 12.6. This one is 12.6 and 12.7, 12.5 and 12.9. Of course, with these kind of shims, doesn't matter how you stack them, your work will be uneven and gappy. Not only that, so obviously your spacer material has to go through the thickness planer first and then cut to size. Moreover, and this is where the addition comes in, the thickness of the spacers must match the thickness of the blade down to 2 decimal places. So in this example, let's take a look at this. If the spacer thickness is 12.6 and my dado blade set is 12.35, the difference in thickness is only 1/4 of a mil. What does 1/4 of a millimeter matter? Well, when you cut the first one, that means it's going to be 1/4 of a millimeter thinner than your spacer, so the spacer doesn't go in. This one does barely, because I adjusted them after the fact, so they go together at all, because they didn't. The two halves needed some hammering and needed some recutting. So 1/4 of a millimeter may force the fibers, may compress the fibers enough together so the first goes together. Something like there, which is on an angle, but just go with it. If you have, so that's 1/4 of a millimeter difference. At the second notch in the wood, this difference is twice this and twice this would be those two numbers. Now you have a difference of 1/2 millimeter. You cannot really compress wood fiber 1/2 millimeter. By the third one, it's a 3/4 of a millimeter difference. By the fourth notch, it's 1 millimeter out. And if the board, if the drawer you're working on, if it's a drawer bottom or whatever, usually wood pieces are narrower, but there can be a deep drawer. So you see the difference in thickness between the spacers and the dado blade, they add up or they multiply. So that's why the thickness of the blade set must match the thickness of the spacers. Lastly, what's with this horrendous fiber blowout? Well, the depth of this notch here in this fence is where the dado blade runs through, but not at the depth. The blade, there you can see, not at the depth of the blade I was using. It was made for something else. And as a result, when this piece of wood travels through it, like so, and the blade travels through it here, the wood here on the other side is not supported and is duly split up all the way to the depth of this notch here. There. I think the length of this is telling. Okay. So that's what's wrong with this. Obviously, this is all garbage. Obviously, these need to be recut right around here and start all over again with the dado set, with the thickness of the dado set to match the thickness of the shims that I make, and then they will work. So that's what I wanted to share with you today about the power of addition.